Okay, thank you. So, good afternoon, everyone. I'm Yunfei from 360 Technology. I'm from Beijing. And I'm very happy to stay here to meet you guys here and make presentations to share my works with you people. And today I'm going to talk about the illegal access point, which also called the rogue AP. And before start our presentations, let me introduce my team. I'm a member of Pixar's team. Pixar's team is a red team of 360 Technology, which is located in Beijing. We was founded in 2015. We focus on wireless and IoT security, and our team is responsible for my company's wireless network security, and we also provide wireless pen testing service. And this year, we published some wireless researches, such as Ghost Tunnel as a Hack in the Box Amsterdam and Black Hat USA Arsenal, and RCE with Capital Proto in the Code Blue, which in Japan just in this month. And in the next month, we will have another talk about the wireless honeypot as the Black Hat Europe. It's also the Arsenal. I'm Yunfei. I'm a wireless security researcher. I focus on the wireless attacks and defense. I used to make presentations on Code Blue, KeyCon, HitCon, Overdrive Conference, and DIFCON Group Beijing. So let's get started. As you know, the Wi-Fi protocol, there are many security faults in the Wi-Fi protocol. So everyone knows the Wi-Fi hacking, more or less, such as for WPA pre-shared key, we can capture the handshakes to capture the password. For WPA Enterprise, which with a Redis server, we can set up a fake access point to collect the username and the password hash, then crack the hash. And for open system with Capital Proto, we can use the MAC bypassing to bypass it. But today, I'm not going to talk about them. I will focus on the rogue AP. So what is a rogue AP? In my presentations, the rogue AP is referred to this access point attached to the company's intranet, but without authorization. Connect to your intranet, but without authorization. Nowadays, people are more tempted than ever to use wireless network. They may want to use their smart devices in the office, so they need the wireless network, but if the company doesn't provide one, the people may try to solve the problem themselves by setting up their own access point, which connect to your company's intranet to access the internet. So that's the rogue AP. And rogue APs are usually set up using a wireless router or use a USB Wi-Fi adapter. They may pose many security threats. And most access points are in the NAT mode, network address translation mode. It will allow different clients to use the same public IP address to access the external network. And the NAT made it difficult to detect those unauthorized clients which behind the NAT network. And the rogue AP is one of the primary targets for an wireless attacker, because these access points are usually configured with weak password or even no password. So maybe anyone can access your intranet. And to make things worse, there are many Wi-Fi password sharing applications. These applications are very popular in my country, China. The 100 millions of access points have shared on these applications. People can use the app to get the Wi-Fi password. So the user can connect to the Wi-Fi connector, the Wi-Fi network for free. That sounds good, but how could they have so many Wi-Fi passwords? Okay, in the early days, when you install the application, it will check the out-sharing Wi-Fi optional as default, as the right picture shows. if you forget to cancel it, so the app will collect new passwords from you, or just use the root privileges to collect all passwords saved in your phones. So many start departments, financial institutions, and other access points have been shared on them, which includes many rogue AP. So maybe you have set a strong Wi-Fi password, and anyone can also access to your internet using this Wi-Fi password sharing applications. And there is a famous incident in China. A supercomputer was imbibed through a rogue AP. A junior high school student found an open Wi-Fi network. He just connect to the Wi-Fi and make a network scanning. Then he found a SSH weak password, so he used the password to log into the host, and suddenly he found it was a node of a supercomputer through the welcome messages. Okay, I'm sure there are many solutions are used by some companies. So let's have a look. Whitelisting. This method chooses to block all access points except those whitelisted. This method is only theoretically feasible because there may are many other companies' access points. They are just around you but not connect to your internet. But if you choose this method, it will block all of them. You can't do that because it's illegal. And MAC correlation. This method is detecting those rogue APs based on the wired and wireless MAC address with a difference of +1 or -1. Can you understand this? When a device, the vendor will assign two consecutive MAC address for a device, wired and wireless network interface card. This method is only works for wireless router devices because they belong to the same vendor. So if the employees use the USB Wi-Fi adapter to set up the rogue AP, just the soft AP, because the wireless MAC address is belong to a different vendor, so the wireless MAC address will be very different from the wired. So this method is limited. Traffic analysis. Identifying based on the traffic analysis. If you find there are many user agents, different user agents, and different operating system initial TTL value from a same host, then we can determine it may be a NAT device. I admit that this method is effective, but this method is only can detect the NAT device, but they are not necessarily the NAT access point, because the NAT network may be created or used by a virtual machine. It's very common. And even if it is a NAT access point, and we can't get the detailed information about the wireless network, such as its SSID, its wireless MAC address, and its associated clients. We need these messages to catch the people who are setting the rogue AP. So this method is also limited. And there are some other measures used by some companies, such as disable USB port, disable the process of creating hotspots. Okay, these methods are effective but very hard to implement, because if you disable the USB ports, the employees will be very inconvenient, and if you choose to disable the process of creating the hotspots, Okay, the employees can use the virtual machine to bypass the police. They can set up the rogue IP in the virtual machine. Okay, so the existing solutions are not perfect, so I want to find a better solution, a better method to find those rogue IPs. Okay, it's time to introduce my new method. My task is to identify all access points on the monitor network. And when I was thinking about this problem, I just wondering if there is such a method that I can make a suspect can forward my test packets from wired to wireless. And once I found these packets in the wireless, then I can determine the sender of the wireless packets is a rogue IP. I repeat it again. Make a suspect forward test packets from wired to wireless. Once I found those packets in the wireless, then I can determine the sender of the wireless packets is a rogue IP. If I choose to use this method, there are two challenges. How to make the NIT device forward my test packets to in the network, in the NIT network. The NIT network is very different. It's very difficult to forward my test packets. And how to carry information which can be identified by my wireless sniffer. Let's look at the first challenges. How to make NIT forward my test packets. Let's have a look at the NIT again. And most access points actually use the NAPT, Network Address Port Translation. It is one type of NIT. And it will allow different clients use the same public IP address with different port numbers to access the external network. At the same time, the internal network is not visible to external. And the NIT device will keep a table of internal to external IP address and port mapping. Let me give you an example. If there are two hosts in the NIT network, and host A will send two packets with two different ports. Packet 1 at the port 1111 and packet 2 on the port 2222. And the host B will send another packet on port 1111. When the three packets through the NIT device, they will have a same IP address, a same public IP address which belong to the NIT device, but with three different ports, 1001, 1002, and 1003. And then the three packets are sent to a server on the internet. And when the server sends back some packets to the NIT device, the NIT device will transmit the packet to host A or host B according to the mapping. Can you understand this? I repeat again. Host A will send two packets on two different ports. And host B will send another packet on port 1111. And when these three packets through the NIT device, it will have a same public IP address, but without three different ports, 1001, 1002, and 1003. And when the server sends back some packets to the NIT device, to the public IP address, but with some ports, and the NIT device will, according to this mapping, to transmit to host A or host B. Okay, now I think you understand how the NIT works. And there are two things we should care about. any TCP session from NAT internal will create a mapping in the NAT table. Any TCP session from NAT internal will create a mapping in the NAT table. And when the TCP connection ends, the mapping may be still kept for a while. There is a timer to decide when to expire. So it's our best opportunity to make an injection. So first, we can choose a target and monitor the TCP traffics to record the host numbers. And there we can use the traffic mirroring or ARP spoofing. And second, generate some test packets and send to the target on that port which we record before. And then some packets will be successful forwarded according to the mapping table. Okay, the challenge 1 have solved. So let's have a look at the challenge 2, how to carry information. Because access points are protected by WFA or WFA2, so we don't have the Wi-Fi password, so we can't connect to the network to receive these packets on the application layer. So we need to find another way. And do you know the smart config technology? It is a popular technology to provide Wi-Fi credentials for smart devices because many smart devices have no user interface, so they need another way to get the Wi-Fi SSID and password from the users. And the smart config solution will use a mobile application to encode the SSID and the password into the length of the packet sequence, then broadcast. And the smart devices will capture the broadcast and then to catch the credentials. And then the smart device can connect to your home Wi-Fi network. Okay, this technology really inspired me because my test packets will be transmitted to 802.11 data frame. So we can also use the length of this data frame to carry information. There is the example. Writing, use the Skype. And you can find there is a red field. We can control the length of the red field. It belongs to the application layer. And then I made an experiment. I set up a rogue IP in the monitor network, and then I send a set of test packets with decreasing length. As the picture shows, I send these packets with the length 17, 16, 15, 14, and the smallest one is 13. At the same time, I use a wireless sniffer to monitor the wireless activities. And the sniffer detect there is also a set of 802.11 data frames with decreasing lengths. They seems like my test packets, but the lengths have changed. The smallest one have changed from 13 to 16.9. Obviously, it is related to the header of TCP IP and is related to the Wi-Fi encryption. So I look at the Wi-Fi protocol. If the Wi-Fi is protected by WPA, which uses the TCP/IP, the TCP/IP will add 20 bytes overhead. So the final length is equal to original length plus TCP/IP header plus IP header plus TCP header. A total of 60 bytes are added. And if the access points are protected by CCMP, the CCMP will add 16 bytes overhead. So the final length is equal to original length plus CCMP plus IP header plus TCP header, a total of 15.6 bytes overhead added. Okay, now we have solved the two challenges, and we understand how to use the length to carry information. So let me make a conclusion about the process of detection. First, we will choose a target to monitor the TCP traffics and record the port number. And second, we will generate some test packets and send to the target on that port, which we record before. And third, identify the test packets by wellness sniffers and make the determination. There is a demo. Let me show you. This is the target one. It is the NAT router, wireless router. And this is the soft IP. Use the USB Wi-Fi adapter to set up the wireless network. And this is my detector. It has a wellness sniffer. Okay, now it's sending the test packets. I just send the packets to all clients in the network. And there is the channel hopping. Channel 1, channel 6, channel 11. And then he found a target. He found a NAT network. The soft IP is also be detected. Advantages. This method works for any NAT or bridge mode access point, no matter which method no matter how you set up the rogue AP. Right? Wi-Fi router, USB adapter is also okay, and this method works for different types of encryption, such as WPA, WPA2 with CCMP or TCP. If it is an open Wi-Fi, it's more easily. And use this method, we can get accurate and detailed information about the rogue AP, including its SSID, wellness MAC address, and the associated wellness clients. And we can also know the wired IP address and the wired MAC address. And knowing this information, we can catch the people who are setting up the rogue AP. And we can use we can disable the IP address as a gateway or use the Wi-Fi DOS attack to block them. Okay, it's the question 10, and maybe this is the hardest part for me because maybe you have found I'm not very good at English, so please use some simple words and speak slowly.
So we have time for a couple of slow questions and simple questions in English. Oh, sorry.
Thank you for the presentation. So if I understood correctly, your method requires you to know, in the case of the NAT, your method requires you to know which ports are used for the NAT translation. So does it always require you to have some kind of traffic monitoring as well on the wired network? Or do you have eventually other methods to find out which ports are used for the NAT translation?
Okay, my detector can send the packets to the target, the suspect. They should be in the same IP address, And the second, the wellness sniffer can detect the wellness activities, which include the whole company's activities. So maybe we should need the sniffers. And for some companies who really have the wellness prevention needs, they have deployed the WIPS, wireless intrusion prevention system, which have many sniffers. So they can directly use these sniffers to do this.
I got a question which is mainly related with existing monitoring applications that would exist. Did you try to link your NatApp detector with any existing monitoring application?
And yes, I have tried many exciting solutions, but they are not can detect all access point, the rogue access point.
Any other question? So we're gonna thank Yunfei.